Because you need to use it's a review of slope. You have to use it later. Okay. All right, you guys know slope so well. The definition of a slope of a line is the ratio of what to what? Rise to run. Good job. Oh, rise over. Same thing. All right. What's another way to represent that then, if you guys are so smart? You were close. Change in y to change in x. That's the equation for a line. Okay. There's a couple of ways to write it. It's represented by the letter m. It's represented by delta y over delta x. And it's also represented by y2 minus y1 divided by x2 minus x1. Okay. Who knows what delta means? Triangle, yeah. But it means something specifically. I've written it on the board. I've already written it on the board. Change. Change. Delta means change in. Change in y, change in x. Delta means change in. Okay, this is an example. I'm not going to go over this. I don't really like this example that much. Slope is a number that describes the steepness of the line. Steepness of the line. Use the form. Okay, so there's a few steps in order to solve slope problems. I want you to write this down on page 61, 62. Write the formula. Write the location of the 2 points. Label your points with x1, y1, x2, y2. Plug in and solve. I'm going to give you guys like a minute to write that down. You have a question? No, write this on page 62 or something. Mm-mm. Okay, I think we're ready to move on. She said, why is it so hot? Are you ready now? We good? All right. So let's look at this first example down here. Example BA. First step I told you guys to do is write the formula. The formula is y2 minus y1 divided by x2 minus x1. Second step. Second step you want to locate your points. We have a point at A, a point at B. A is at 2, 3. B is at 7, 5. Step number 3, label x1, y1, x2, y2. x1, y1, x2, y2. Fourth step, plug it into your equation. y2 is 5 minus y1 is 3 divided by 7 minus 2. That is equal to 2 over 5. So our slope is equal to 2 over 5. We can check this a really, really easy way. Does anyone know the really easy way we can check this? So we should be able to count up 2, 1, 2, and to the right 5, 1, 2, 3, 4, 5. Yep, that's correct. Because you won't always have a graph. Because you won't always have a graph. Because you won't always have a graph. Okay, so you think, okay. Yeah. I'm not going to write the name. We'll just say someone, 7th period, thinks it's 1. Okay. Or 4 over, Okay, so maybe that's why we don't just count, because sometimes you count wrong. y2, first step is I write the formula. y2 minus y1 divided by x2 minus x1. Second step, what's my second step? Who should I call on? What's the second step? Label our points. We have a h, which is at 2, 6. We have a G, which is at 6, 2. What's our third step? X1, Y1, X2, Y2. What's our fourth step? Plug it in like Glade. 2 minus 6 divided by 6 minus 2. 2 minus 6 is negative 4. 6 minus 2 is 4. That is equal to negative 1. So M is equal to negative 1 is what I should have wrote. Oops. Alright, ready to move on? Yeah. Take the pass, which is just a string. See if the passes are around there. All right. Negative slopes go downhill. Positive slopes go uphill. You guys should already know this. There's two complicated ones. A horizontal slope, which is a slope of 0, and a... Well, because he's falling. So, why is this a slope of 0? Well, let's think about it. We know slope is represented by m, and I have a question. It's rise over run, right? So is there any change in the rise in this line? No. So it's going to be 0. There's no risers. There's no rise between these two. No rise or run. Sorry, no, there's no rise. So it's going to be 0. Over, well, it doesn't matter, any number. So a negative slope will look like m is equal to 0 over any number. So I'm going to just write some number. Okay? This one, we're going to do the same process. Think about it for a second. What do you think this one's going to look like? Look at what's increasing and what's not staying the same. It's going to be some number over 0. Over 0. Okay? Because look at it. We have a y increasing or decreasing, but there's no change in x. So the change in x is 0. That's why the 0 is on the bottom here. This is the opposite. There's no change in y. That's why those 0 is on the top. So the slope for this is called 0. The slope is 0. The slope for this one is actually called undefined. You're doing good. All right, I actually really like this problem. Justin is driving from home to his college dormitory. I hope he makes it just in time.
Bruh. Really? Really?
That joke was hilarious. Okay, I said, let me repeat that joke because there's not near. Valeria, why aren't you paying attention? Okay, so the joke was, maybe because she wasn't paying attention to my jokes. The joke was, Justin is arriving from home to his college dormitory, and then I said, I hope he makes it just in time. Hey, I'll take that. That's passing. No, it's not. No. I don't want sympathy laughs. Okay. At 4 p.m., he's at 260 miles from home. At 7 p.m., he's 555 miles away from home. Find and interpret the slope of the line. So, first step, write the equation. x2, ooh, that's bad. y2, yeah, I was testing you, minus y1 divided by x2 minus x1. Second step, locate your points. I'm going to call this point A. I'm going to call this point B. Point A is at 260. B is at 455. All right, third step, label them. x1, y1, x2, y2. Fourth step, plug them in. y2 is 455 minus 260 divided by 7 minus 4. What does that equal to? What's 455 minus 260? 195. I'm going to write it here. 195. What is 4 minus 3? 3. Okay. Which is equal to 65, yes. So, I have a question. Does that have any meaning to you?
Yes.
What meaning does that have to you? Yep, it is a number. Remember when I said math and numbers mean nothing unless you give them units? So let's have when we give these units. What was the unit for this number here? Miles. What was the unit for this one here? Time, which was in hours. 195 miles in 3 hours. You can simplify that by dividing it by 3, and it becomes 65 miles per 1 hour. Now do you see what I'm saying? Before, with no units, I'm just showing that there's 1 hour. You don't have to write it over 1 hour. So, Brianna, Juan, come on. Okay. Well, I'm trying to continue with my class. You're not letting me. So, remember when I was saying these calculations are all meaningless until you put a unit to it? We were like, what does that even mean, right? And you guys even told me, we don't know what that means. We put the units, and you guys all know this meant miles per hour. Do you see why units are so important? Time for you to get a watch. Oh, too bad I can't use that. All right. Now we're getting into the actual lecture. Everything beforehand was a review. Now we're going to do the actual part of this lecture. This is, I think, new for you guys. Parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same blank. Vertex? No, lines do not have a vertex. Same slope. But different what? Lines don't have angles. Y-intercepts. Good job. Y-intercepts. Any two vertical lines are parallel. Perpendicular lines theory. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is, does anyone know? If the slope was the same, wouldn't they be parallel? But, yeah, they do have to be different. Not 0. It has to be negative something. Nope. Negative 1. Has to be negative 1. So if you multiply the two slopes together and it's equal to negative 1, that is, the lines are perpendicular. Okay? Don't worry about this part here. Yeah, cross it out. Well, if you all want to know what the answer is the answer is negative reciprocal and horizontal and vertical lines are perpendicular. But don't worry about that for right now. All right, use the slope to determine whether the lines are parallel, perpendicular, or neither. So if they're parallel, the slopes will be the same. If they're perpendicular, the slopes will be negative 1. And if they're neither, it's going to be neither of those two options. So we have to find the slope for two different lines, this line and this line. So I'm going to draw a line here so we can separate those two lines. It's kind of like two problems in one. I know. Oh boy. So, first slope we're going to find is a line of UV. Out of these 4 points, which 2 of those points do you think we're going to use for line U, V? U and V. But Mr. Rink, why aren't we using X and Y? Because it's line U, V. Use these 2 points. So, first step, write the equation. Y2 minus Y1 over X2 minus X1. UV. We have U, which is at 0, 2. We have V, which is at -1, -1. What's our next step? Label them. X1, Y1, X2, Y2. Plug in. -1 minus 2 divided by -1 minus 0. -1 minus 2 is going to be -3. -1 minus 0 is going to be -1. What does this simplify to be? You were right. Oh, 3. 3. We're half done. We gotta do the other line now. This other line is called XY. So which 2 points do you think we're going to use for XY? X and Y, yes. 3, 1, and -3, 3. What's our next step? Label them. X1, Y1, X2, Y2. Plug it in. We're going to have 3 minus 1 over -3 minus 3. That ends up being 2 over -6, which simplifies to be -1 over 3. So, is 3 the exact same thing as -1 over 3? Yes, those are the exact same thing? Yeah, so can those be parallel? No, so we're going to scratch that off the list. Let's see if they're perpendicular. If they're perpendicular, you multiply those 2 slopes together, this should be equal to -1. Let's multiply those 2 slopes together. Our first slope is 3. I'm going to do 3 over 1 to represent that, times -1 over 3. That is -3 over 3. -3 over 3 is equal to -1. So are those parallel? Good. Yes. No, they're not perpendicular. They're not parallel. They are perpendicular. Okay? When I multiply, I did 3, which is the same as 3 over 1, times -1 over 3. Multiply across. All right, use the slope to determine whether the lines are parallel, perpendicular, or neither. Same process. Try doing this one on your own. I'm going to give you guys a couple of minutes to do this one on your own. You should be able to do it. Blake. Not Blake. Rob. Rob. Thank you. 3 minutes to finish this. So, line, because it's like 2 different problems. We're going to do x2 minus x1 divided by, I said y2 minus y1, I'm sorry, divided by x2 minus x1. We're going to have line AB, which is these 2. We have A, which is at 2, 1. We have B, which is at 1, 5. We have x1, y1, x2, y2. So plug it in. 5 minus 1 divided by 1 minus 2. That ends up being 4. It's a weird 4 over -1, which is -4. Good job. Next one. We have CD, which is C is at 4, 2, D is at 5, negative 2. Label it. Plug it in. Negative 2 minus 2, and then 5 minus 4. Well, that happens to be negative 4 over 1, which is, so are these two the same? Okay, you guys want to do another example? Are you guys good? Okay, take out your homework. By the way, this is the answer to this one is going to be neither. Oh, Blake's already got it. Take out your homework. Sure. Your homework. Wait, is it Friday?
Yes.
Double homework Fridays. Wait, is it? It's not Friday?
No, it's Thursday.
Oh, because you know what I was going to do? I was going to say, you guys have been so good, instead of double homework Friday, I was going to give you no homework Friday. But hold up, it's not Friday. So your homework is going to be 17, 18, 19. 17, 18, 19. And we will have a homework quiz Monday over 17, 18, 19.
I already got the
Mhm.
parallel, neither and parallel.
Imagine you'd be right.
All right, I'm going to take attendance.